What is up, Volt Heads? Today I'm very pleased to introduce the very first bundle from the brand new Umbrella Modular Cyclic Oscillations. The Cyclic Oscillations bundle includes 4 Lfos that are all clock syncable. They can be run at audio rate as well as low frequency rate. The frequency and the shape is modulatable. In addition, there are 2 ways to mix all of these modulation sources. A very sweet crossfader with 4 inputs and 3 outputs, as well as a mixer, attenuator, offsetter, mingler, inverter, all sorts of fun stuff. So with all that in mind, let's take a look. Taking a look first at the 4 Lfos, or the 4 oscillators if you prefer. They all operate the same way. They have the same inputs, the same outputs, and the same controls. But what's different between them is there are different shapes. And these different shapes were targeted, not at random, but to give a different flavor to each. We've named each of these oscillators after their flavor. We have sharp, smooth, spike, and straight. Now of this group, my favorite may be smooth. Let's take a look at that. So we have a frequency knob that controls how fast the LFO or oscillator is running, as well as a smooth morphing shape selector. Now down at the bottom, we have outputs. And one of the really cool things about these outputs is these are all ratios of each other. So I'm going to go ahead and grab this first one, which is labeled 1-1. I'll patch it into the oscilloscope. You can see that's oscillating. Now I'm going to grab 1-2. And one of the things you may notice about 1-2 is that there's a relationship here. 1-2 is running at exactly double the frequency of 1-1. And as you might guess, 1-3 is running at a third of the frequency of 1-1. And likewise, 1-4 is running at a quarter. Now all these express an interesting ratio to each other. And one of my favorite things about this module is it's easy to just drop it in a patch and hook all 4 of these modulation sources up to something. And suddenly now, in a very small amount of space, you have 4 different things that all have a relationship, but are all doing a different thing. As we move the frequency knob, of course, they all slow down and speed up together. Now, one thing here is, as I'm moving the frequency knob, you can see here that it is giving the rate in both hertz and in absolute time at milliseconds. Now, the absolute time is the amount of time that it takes for an entire cycle to complete. And the frequency and the time that we're looking at is related to 1-1. So you can do the math to figure out what the other jacks would be. Now, one of the neat things here is that you can enter both time and frequency when you edit the tooltip. So for example, if I wanted to go to, we'll just do 3 hertz. There we go. What's neat is you can also enter time as well. So let's say that I wanted an oscillator where 1-1 is going to last 10 seconds. I can type in 10 and put in S, and it will give me the corresponding frequency based on the seconds that I gave it. Also, if you're wondering, it does respect other times like minute, which is pretty crazy. And this will go all the way down to 0.1 hertz, which is roughly equal to 2.5 minutes. Now, remember that the frequency that we're setting here is controlling the 1-1 output, which means that this one here, this 1-4 output, will be 4 times as slow. So the minimum speed that we can go here is 10 minutes. That's right, you can have an oscillator, an LFO, that takes 10 minutes to complete an entire cycle if you would really like. Anyways, I'm going to put that back up here at something that's a little quicker. All right, so that's frequency. And just a reminder, the frequency knob works the same on all of these other ones. Actually, let's take a look at one of the other ones. I'm going to go with spike. Spike has some interesting shapes here that are oriented around, well, just like the name implies, a little bit more spikiness. Let's slow that down a bit so we can see them easier. You can see this very first shape is a shark tooth. Now let's look at the shape knob now. The way the shape knob works is as you turn it, it will slowly morph between the three shapes. So each of these modules has three shapes, 1, 2, and 3. So here you can see that on this particular spike one, we get this, in development, I called this the heartbeat shape. This is neat if you want to have rhythmic modulation that is not constantly flowing up and down, but just occasionally appears as a little blip. In fact, it makes a really nice modulation, rhythmic modulation addition to whatever you're working on. Now, one of the interesting things about all of these shapes is that the third shape on the far right, as I scrub the knob over, that shape is always going to be random. And so if we watch this for a second, we can see that now suddenly all of these are doing something different. We're kind of getting this random amplitude, but it descends, and you can see that all 4 of the speeds have a different random amount, which is neat because now we're getting a lot of variety. Of course, if we set these knob positions somewhere in between, we're going to get a mix of both. So here you can see we were getting that heartbeat along with a little bit of random stutters along the way. It's going to be pretty cool. Likewise over here, if we go in between the heartbeat and the shark tooth, we're kind of getting this interesting up and down thing going on. I'm just going to keep moving through all these to let you see the shapes. Straight, as you may guess, is a LFO that is based around square and pulse width waves. So here, as we have this one, as we scrub upwards, we start to increase the pulse width. And then as we go over here into the random, we get a bit more into this kind of squared random. Sharp is based around saw waves. So here you can see we have bipolar alternating saw wave. And as we scrub upwards, I find this one really interesting. I'm going to slow this down so we can see it a bit more. This stacks 3 saw waves in a descending saw wave envelope type pattern, which I think is really cool. If you use this to modulate things like filters, you will get a grittier sound out of it. And then as we continue over to the right, again, we have random. And this one's interesting because you can see that what happens is it's picking a random amount of saw waves to play through a single cycle. So if you watch here, it will randomly pick 1, 2, 3, 4, or 5 saw waves, and it will play it through as a single cycle, which is pretty fun. All right, and then bringing us back around to smooth. This first shape is the classic triangle. As we move up, we get the classic sine wave. And then as we move into random, we get a smoothed random sine wave type of thing. If I slow this down, it's a little bit easier to see. So you can see it's kind of like a sine wave that's just a little lost and doesn't know where it's going. This is probably my favorite modulation source of the bunch because I just like how it kind of wanders around and it gives you modulation, but you're never quite sure what to expect. All right, so that's all of the shapes of all of these modules. That's all fairly straightforward. Now, you might say, what if I want to have the oscillations tempo synced to my patch? Let's take a look at that next. I have added a few modules here to my patch. Let me just go over those real quick. First, we have sync generator. If you are using voltage modular in standalone mode, this is likely what you want to use to give yourself a sync tempo signal. If you are using voltage modular as a plugin inside of your DAW, then you do not need this. Instead, you can use the sync out up here on the top of VM. There's also a sync divider. So this LFO, you can see there's a clock jack. It is expecting a clock signal, not a sync signal. So do not patch sync directly in. Instead, you want a clock signal. So either take sync out to a sync divider, or in this case, because I'm running in standalone, I'm going to take the sync generator out and patch that into sync divider. Now, once we have that patched into sync divider, we can patch the clock out into the clock input of the module. So you can see as soon as I did that, tempo synced up immediately. This is actually something that's really nice about all of these LFOs is the timing and the synchronization is very precise. In fact, there's a little bit of code to detect when the tempo changes, and it will clear out any averages that it has, and it will try to give you as fast of an update of a clock signal as is possible. Anyways, little ad for tempo sync over. You can see here that I've patched clock out to this clock input on the LFO. Sure enough, it is going at the rate of whatever our clock signal is. If I was to increase this clock signal to 1/8, you can see here that, yep, we're speeding up. Now, there's something interesting that changes as soon as we attach a clock jack in on any of these LFOs. The frequency knob changes instead to be a divider or multiplier. So when it is straight up and down, you can see here when I mouse over, it says 1x. When it's straight up and down, the LFO will be running exactly at the clock rate that has been given. To the left, it will become a division of that. So here you can see we're now running at 1/2 of the clock, all the way down to, at its lowest, it'll be 1/8 of the clock. Likewise, as we turn it to the right, we can speed it up. So here you can see I'm at 2x, 3x, 4x, and so on, all the way up to 8x. So really neat if you have a clock that you're already using for something else and you just want to speed this up relative to the clock you already have. This will actually snap to those divisions evenly. And of course, shape works the same as well when you're in clock mode. Now there's another jack to the left of clock, and that is called reset. What reset will do, if you're familiar with hard sync on an oscillator, that's what reset does. So a single oscillation will start from here, it'll go all the way through a cycle, and then it will repeat. If we patch a trigger into reset and we activate that trigger, what it will do is it will start the waveform over. So watch over here on the scope. I'm going to hit the button to reset it, and it will restart all of the shapes. So reset and reset. If I click it a bunch of times, you can see that we're resetting, and it basically just starts the shape over. Now, an interesting thing here you notice is that it starts all 4 of the outputs over from the beginning, so they're all in synchronization. There will be occasional cases where this matters. If you want the LFO to both have the same time and to begin exactly with, for example, your sequencer or your DAW, this is a case where you would want to use reset. So I'll give you an example. If you are using Voltage Modular as a plugin and you want the LFO to always begin when the transport of your DAW begins, the setup that you would want is, first of all, we would take sync out to sync divider in, and of course we would patch clock out to clock in, and then we would take play, which is a trigger that will fire whenever the DAW begins to play, and we'll patch that to reset. With this configuration, every time you start playback in your DAW, the LFO will restart all of its shapes, and it will always be in synchronization every single time on the same spot. I've gone ahead and cleared off some modules. Let's talk about the last 2 features of this LFO, and that is frequency and shape modulation. So over here on the left, of course, we've got sharp going. I'm going to patch that just so we can see that, and actually I'm going to slow that down a bit. There we go. We'll use a classic saw shape for this demo. There are 2 inputs for each of the LFOs, frequency modulation and shape modulation. Now, as you would guess, what these will do is they will use a control voltage to change the frequency or a control voltage to change the shape. So in this case, I'm going to patch the 1/1 of this sharp one into frequency modulation. There you can see as the shape gets high, we speed up, and as it gets low into the negatives, we slow down. Now above both of these modulation jacks is the attenuator knob. And what this controls is how much of the incoming voltage will change the frequency. As we pull it to the middle position, here you can see we're getting it almost says 0 there. That will decrease the amount of modulation. You can see we've got almost none happening. And as we increase it, it will apply the maximum amount of modulation to modulating the frequency or shape respectively. The attenuation knob works the same on the shape side. Now, if we go past noon and we start going far to the left here, you can see that the percentage becomes a negative. And so now we're inverting the voltage that comes in, and we're applying that inverted voltage to modulating frequency. You can see in this case we're getting the same effect, it's just one of these happens before the other, right? When I turn it to the right, you can see we're kind of just phase shifting it by 180 degrees. This works for shape modulation as well, which is pretty neat. I'm going to park this in the middle, and the reason I'm parking this in the middle is because our incoming signal is both positive and negative, and so basically it means this control voltage will wiggle the shape back and forth between these two.